Now we are going to solve these exercises, and we start with this one. In this one, it tells us that a volcano is shooting blobs of lava from the summit. Now we have to think about, look, first of all, it has V0 here. And you have to think always that when something is going upwards, nothing can go upwards without actually giving it an initial push. When you give it an initial push, it means you are giving it an initial speed. Okay, so this is something you have to note out. So it says that a geologist is observing the eruption and he's using a stopwatch to time the flight of a particular lava bomb that is projected straight upwards. So if I try to draw more easily this situation, well, I have a lava drop, a lava bomb, and it's giving me on the screen the axes. So the axes start from 0 at this level, so this is 0 level, and it goes up forward. This is x. Okay, so what I do learn from this graph, or this one and the image here, I learned that x0 is actually 0. If you look at it, x0 is 0, and v0 is not 0, but I need to know it. v0 is different than 0. Okay, this is something that I have to know. Now it tells me that if the time for it to rise and fall back to its launch height is 4.75 seconds, what does that mean? It means that this lava has went up, it stopped, and then it went back. Okay, so this is the rise and this is the fall. And he's telling me that the entire time, so time total, I will call it, for the rise and fall is equal to 4.75 seconds. What he wants to know is, what is the initial speed first, and how high did it go? So let's answer first of the initial speed. So first thing he wants to know, v0 equals how much? Okay, great. Now what should I do in this case? I have to think about what I have, what I know in this situation. Okay, first thing, time, I have time, but I have the time for the entire flight or the entire trip. What happens in this trip? It goes from 0, it goes from v0, so this is here v0, this is v0, so with a certain initial speed, it goes up, and then it falls. What happens to fall? In order for it to fall down, it has reached actually a speed here at this point. If we call this v final, what is the v final in this case? Well, it's 0, because obviously it has stopped, and then it fall back. So during the rise of it, it starts from v0 and ends from v final. So v final, I have it in this rise. Do I have the time for the rise? Actually, yes. So let's do it the following. Let's take the rise part of the motion. So let's take, and I will, the rise part of the motion. In the rise part, I have v0, I need to find it. And what is the time of the rise? Well, actually, the time of the rise is half of this one. So time of the rise is actually time total over 2. It's the total time, because it's go up and go down, over 2. So that's 4.75 over 2. This will give me the time for the rise motion. So the rise motion goes from v0 that I need to find and reaches the point where it stops, so the v final there is 0 over 2. Okay, so this would give me a value of, let me 4.75 divided by 2, it's 2.375 seconds. So this is going to be 2.375 seconds. Okay, great. So now what do I have? I can rearrange the problem in a nicer way. So I can consider only the rise part. So I would do, then I have the rising part of the motion. What do I have for the rising part? I have x. I have started from 0. So this started from 0. It went up until it reaches v final equals 0. This is what I have. V final equals 0. I have v initial equal v0. I have to find it. This is the question. And I have determined that the time for this part of the motion between these two speeds, time equal 2.375 second. Okay, great. So if you look back to your equations, well, if we have v final, we have the time, and we have v initial, what kind of relation we need to find initial? What kind of relation we have? Well, we know that the acceleration is v final minus v initial divided by the time. Now, if we look into these, the time, I just determined it, so I have it. V initial, I want it. V final, I have it. I still need the acceleration. Now, this is what? I mean, if it's going up, if I take it at any point, what does it have on it? Well, it has, obviously, the weight, which is equal to mg. So, actually, the acceleration that I have is the acceleration of gravity, right? But now I have to notice one thing. Is the acceleration here? This is the acceleration of gravity. I will write it like this, acceleration of gravity. Now, you might think that the acceleration of gravity is 10 or 9.81, which is correct in values. But is it a positive acceleration or negative acceleration? How do you know that? Well, it's easy. Is this object, which is the lava bomb, slowing down or speeding up? Well, it's slowing down because it started with a certain speed and then reached 0. So it has been slowing down. So we have to take this note, and I will write it like this. We have to note that since the lava bomb is slowing down when it is going straight upwards, this means that the acceleration is definitely what? Is negative sign. لأنه v final is 0. So minus v initial, so acceleration is going to be negative, right? So it means the acceleration in this problem is minus. Okay? This implies that the acceleration in this problem is equal to minus 9.8 meter per second. So it's the value of the acceleration of gravity, but with a minus value. Okay? So now I have everything. So now I have A equal v final minus v initial over time, which gives me, if I arrange the formula, it gives me v final minus v initial equals A times t. Now I have everything. V final is 0. This is 0. So I have minus v initial, which I want, equals A is minus 9.8 minus 9.81 times the time was 2.375 seconds, and then I have this gives me the V initial, which should be around 23. So let me do it quickly. 3.75. So 2.375 times 9.81, and this gives me 23.29. So almost 23.3. 23.3, and it's a speed. So what is the unit of it? Meter per second. Okay, great.